12.1 is inference for linear regression. Now this is combining two things that we've done already. We've been doing inference for the last however many chapters, from like chapter 7 or 8 on. And then we did linear regression way back in chapter 3, I believe. So all we're doing now is combining the two. So if you remember way back when, this table kind of sums things up. We had a slope, a y-intercept, and a least squares regression line when we did all this. Population, statistic. And here's the interpretation for slope if you don't remember that. So with each additional x, predicted y goes up or down by whatever your slope is. And the y-intercept interpretation is when x is 0, the predicted y is whatever that y-intercept is. Remember, we were predicting y using slope and y-intercept. So the hat is the prediction. Those are your two formulas, population and statistic. Standard deviation of the residuals. Remember, the residual is the actual point minus the predicted point. So the actual points typically vary by whatever it is from the predicted. And then the standard deviation of the slope is kind of something new. If we repeat many, many times our process, the slope will typically vary by blank from the true slope. So basically, we're not going to know things about the population, but we're going to use a sample to estimate things about the population. We're going to do confidence intervals for slope. So your formula, general formula for all confidence intervals is point estimate plus or minus margin of error. And specifically for this, we have our slope is from our sample is our point estimate plus or minus t star again times the standard error of the slopes. Degrees of freedom is going to be n minus 2. And to find the standard error of the slopes, you do standard deviation of the residuals over standard deviation of your x value, your x variable, times the square root of n minus 1. The calculator function for this is a linear regression t-interval. Now, here's kind of the key. When you're doing these, I'm not too concerned that you can do them by hand. I'm more concerned that you can do them with the calculator and explain to me what they mean. So for today, try practicing with the calculator. Here are your conditions for doing either a significance test or a confidence interval. So the first is linear. To look at linear, you look at the scatter plot. Make sure that the pattern is linear and not quadratic, exponential, anything like that. So that's how you check that condition. The independent condition, we've been working with this for a while. That's your 10% condition. The normal condition, this one, you have to look at a dot plot of the residuals. So for the normal condition, find your residuals. Hopefully you remember how to do that from chapter 3, and then make a dot plot or a histogram or something of those and see if it looks normal. For equal standard deviation, that's the E, you need to look at the residual plot. And there needs to be no type of pattern in your residual plot. Remember, your residual plot plots your X list versus the residuals. The main thing to look out for is like a Christmas tree pattern that would look something like this. So as your X gets bigger, your Y gets bigger. Your residual gets bigger. And then the random condition needs to be a simple random sample or a random assignment experiment. So those are the conditions. If you are struggling with them a little bit, I will be doing examples tomorrow and talk about them a little bit more, but also look through your book through the examples that they did. For a significance test, general formula, you get your test statistic, taking your statistic minus the null over the standard deviation. So now your statistic is your slope from your sample. Your null hypothesis would be your population slope. Most of the time, your null hypothesis is going to be 0. There is no linear relationship, positive or negative, but sometimes it might give you a slope to work with over the standard error of your slopes. Now, like I said before, try using the calculator functions when you do this. I'm not too concerned that you can do it by hand, but practice using the calculator functions. So that's kind of the general summary of this. I will be doing an example video or two tomorrow, probably one with a confidence interval and one with a significance test showing you all this stuff. But for now, today, make sure you take that survey and you get a start on the homework, try them, and then remember office hours start at 1. So you can ask questions during that if you have them.